Hello everybody. So now we are discussing the second or the next step, which is the meshing. And to remind ourselves with this meshing, the meshing is equivalent to the incrementation of the space or the distance in the plug flow reactor, or of the time in any unsteady state process. This incrementation is meant to break the whole length or the independent variable into small increments, and so that we can apply our governing equations or the differential equations on these small increments. So you solve for the first increment, then from the outputs of the first you can solve the second, and so on. So this is in the one dimensions. In the two dimension case like ours, it is the system is broken into triangles, which is called meshing, and these triangles are what the software do the calculations on. And you see that there are a lot of triangles. They have common vertex and common sides. So any triangle must have common vertex and common triangle with the and common edge with the surrounding triangles. This is a very important point to notice. This is nothing that we will do by ourselves. This is the software that's gonna do this. But this is a good piece of information to understand. And the software assumes that each one of these triangles is a homogeneous area, so it has constant concentration or constant temperature or constant pressure, whatever the parameter that you want. So if you want to get a higher quality of the solution, or to improve the quality of the solution, you have to use smaller sized triangles. This will make the solution much better, and the resolution of the distribution is higher. And this is something that we will see in the software. So let's go to the toolbox and see how we can do the meshing. So after getting all the information done that we have regarding the drawing of the geometry and defining the boundary conditions, we need to, and on the partial differential equation, of course, we can go to the mesh and click on the mesh mode. And for the mesh mode, you would see that the software has already created these triangles without any interference from you. You just click on it, and they all satisfy the criteria, and they are all okay. The ideal shape of a triangle in the mesh is an equilateral shape. So the ideal shape, or in the ideal world, the triangle, all the triangles must be equilateral. They have the same sides for the three sides of the triangle, and all the angles are 60 degrees inside the triangle. So this is the theoretical case. But if you check what we have here, you'd find triangles like this that is not an equilateral triangle. This is not an equilateral triangle. You'd find many of them that are not equilateral, and that's why we have in the mesh here what's called the mesh quality, or triangle quality. So if you click on display triangle quality, it is going to show you the quality as like a color code. So you have the purple color as 1, and the blue is 0.7. So you'd see all these non-equilateral triangles have bluish colors, and all the equilateral triangles have this purple color. So this is something that it might not make a big issue for us, because the software will deal with it. But there is an option for the software to improve the quality of the mesh, which is called jiggle mesh. By jiggle mesh, the software will change the coordinates of some of the nodes to make the triangles more equilateral than they are now. So if you jiggle the mesh and then display the triangle quality here, it's gonna be like a little better. It might not be clear here, but it's gonna be clearer when we do the mesh refining. So when we refine the mesh, when we click here, this is breaking each one of these triangles into smaller triangles. So it's refining the mesh, reducing the size of the mesh, and this is how the shape looks like. So now if we show the triangle quality, you'd see that they're almost the same areas that didn't have good quality. But if we jiggle the mesh and then display triangle quality, you'd find that the blue triangles are less than before. There were some here more, some here more, some here more. So this is kind of a good thing, that you can improve the quality of the mesh that you have. So I have checked the initializing mesh, the jiggle mesh, and display triangle quality. One thing that might be of interest to people is to display the nodes, but let's use the big size of the triangles or unrefined mesh and display the node labels and the triangle labels. So you'd see here that each triangle has a number and each node has a number. So if you want to show this, you can, so that you know which nodes are of interest for you. So you know that, for instance, for this side you have nodes 29, 28, 7, 6, 5, 4, 3, 2, 21. So these are the nodes that you have here. I have 1, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 2. Anyways, so I don't understand exactly how it distributes the numbers, but it seems that 1, 2, 3, 4 are the 4 corners of the shape, and then it starts 3 somewhere else. So, and it's not something that I will really care about, but this is something nice to see. For the triangles, you see it starts from here 1, 2, 3, 4, 5, 6 for the sides, and it goes kind of like spiral shape until it reaches the maximum value here in the center. So the maximum value is 256. I think this is the biggest number that we have, and the biggest node number is 147, which is in the center. So it seems that it goes from the sides into the center. Anyway, so this is an option in case you want to know the number of the node and the number of the triangles in the mesh. So this is almost everything. There is one more thing here, which is the parameters, and in this parameters it gives you information about the how you create the mesh. I have no experience with this, so I'm not gonna go into the details, but I believe this is how the mesher version is, how the software creates the mesh. We have R2013A and pre-R2013A. It seems that there has been some differences, and how the mesh juggling takes place, how you refine the mesh. So if somebody is interested, you can read more about this and see how this can be done, or what do they do, and maybe this affects the solution somehow. So this is all for meshing, and by finishing the meshing, we are ready to solve the problem. So this is gonna be the topic of the next video. So I'll see you then. Goodbye.